Okay, quick chat about the UG versus height lab. Mr. Eaton students, if you're watching this, we did this a little differently, so you'll have to review your own lab, but the things I'm saying here are good with regard to conservation of energy. We measured this height. Yeah. We had a Sonic Ranger here. We measured, hooked to a LabQuest 2, LQ2. We measured this velocity of the cart when it was at the very bottom. We knew that UG equals EK, and so we did several different heights and got several different kinetic energies. I think I only made y'all do 4. But the bottom line is, whatever number this is, let's say it's 100 joules, right? That is going to equal, yeah, I think you were asked to do UG versus height. Yeah. Yeah, and that would have been a linear plot because UG would equal the kinetic at the bottom since there's no work done by friction. And the UG is also MGH. So if I plot UG versus H, then the slope should be MG. So there's that. If I were doing this on a test, AP exam or otherwise, I would say conservation of energy. I want to put that basic physics that I know is true all the time at the top. Then I want to have the conservation of energy equation. Then I want to, truth is, I would probably say MGH, if I want to test, 1/2 MV squared. I could note that M doesn't matter, right? So it doesn't matter what the M is. This will still be conserved because that's not a factor. The other thing I want to point out before I shut it down is that if this weren't a negligible friction track and car, then friction would act, I don't know what's happening now. Friction would act this way, force friction, right? I think I'm gonna have to clear this, it's getting too busy. Okay, so if it weren't a negligible track, then the car would be here. This would still be conservation of energy. UG equals EK. MGH equals 1/2 MV squared. Yeah, all that would be true. The mass still wouldn't matter. But if friction weren't negligible, then we would have a force of friction here through a distance x here, right? So we know that work equals F dot x. The F would be force friction. This would be work done by friction. And we can tell that friction is taking energy away from the system. So if we look and see that the angle between the force, as we talked about, right, positive and negative work, the angle between the force and x, right, the force is pointing this way, x is pointing this way, is 180. So it would be, oh no, that's bad. It would be work done by friction equals F friction x cosine 180. And that's going to give us a negative value, right? Because the cosine of 180 is a -1. So that's going to give us negative work. That should make sense because friction is taking energy away from the system and moving it to thermal. So if I wanted to rewrite my equation, I could say conservation of energy, UG equals EK. If nothing is friction is negligible. But if friction is not negligible, then it would equal EK plus the work done by friction. So let's look what that would look like. If I had 100 joules of gravitational potential energy at the top, right here, right? There's my car. It has an M. It has a height. It is on the earth, right? So if that equaled 100 joules, then let's say I only got 80, when I measured my velocity, I only got 80 joules worth of energy stored in motion, then that would make it easy for me to say, hey, must be 20 joules, right? 20 joules of work done by friction, right? So that 20, what that shows us is conservation for the whole thing. I started with 100. It's only moving with 80 joules of kinetic energy at the bottom. So 20 must have gone into thermal because the rubbing on the track, the friction. So hope that's helpful. Thanks for tuning in.